Section 9.3 is about graphing quadratic functions. So when we say quadratic, we just mean that it's a polynomial of degree 2. So that means that x squared is the highest power. And so it should look like f of x equals ax squared plus bx plus c. That's what we mean by quadratic function. But then these two definitions here really work for any curve or function. It's just a definition of x-intercept and y-intercept. So x-intercepts, and this is sort of notable, that it could be more than one. And these occur when the graph crosses or touches the x-axis, meaning where y equals 0. So x-intercepts are where y equals 0. Y-intercepts are where x equals 0 because that's where the graph crosses the y-axis. So with both of these, we're setting one variable equal to 0 and seeing what the other variable is doing. So let's try an example, see what this looks like. It says a toy rocket is shot in the air at a speed of 48 feet per second. Its height after x seconds is given by this function. So here, h is height in feet. And I know the units because of this feet per second. And they tell us that x is in seconds and it's time. So it's time in seconds. With any word problem, it's always important to sort of figure out what these variables are telling us. Then it says algebraically determine the y-intercept. So remember, y-intercept always means x equals 0, no matter what the function is. So really what that tends to mean, though, is that all we do is plug in 0. So in function notation, we call that h of 0. So where there's an x, I'm going to put a 0. Plus 48 times 0. So h of 0 is 0 plus 0, which equals 0. So what this tells us is that the y-intercept is the point 0, 0, because when I plugged in x equals 0, I got that y equals 0. But in terms of this whole toy rocket thing, it means the starting height when time is 0 is 0 feet. So starting height is 0 feet. And by starting, I mean time 0. So when time is 0, the height is 0. And if you look at this lovely picture they gave us, oh look, 0, 0 is a point on the graph. But this is how to show that algebraically. So let's try another one. Algebraically determine the x-intercepts. So x-intercepts are where y equals 0. But here, there is no y, except that this function is the y value. So remember, function values are the same as y values. So we're saying 0 equal to negative 16x squared plus 48x. It's always a more involved process in order to find x-intercepts, because we have to solve for x now. It's not just plug in and type in a calculator. It's always sort of an algebraic process. And so we have to pay attention to how many x's we have and what their exponents are. Because if all we had was x to the first, we'd just get x by itself and we're done. If all we had was x squared and we didn't have this x term, I could just get the x squared by itself and square root both sides. But as soon as we have both x squared and x, we have to use quadratic formula. In Math 95, you will learn a third option, but in Math 65, if we see both x squared and x, we need to use the quadratic formula. You got to make sure 0 is on one side in order to use the quadratic formula, but for finding x-intercepts, we should have that anyway. And then we just need to make sure we know what a, b, and c are. A is the number in front of x squared. B is the number in front of x. And here, there is no c. So if you look at this format, this plus c, we don't have that. So c equals 0. That's fine. Don't get freaked out because of 0. 0 is a lovely number. And maybe it'll even make this easier for us. I'm hoping by now we're all quadratic formula experts. We've been using it quite a while. But keep practicing. Try writing it, the formula on your paper right now if it's something that you need to keep practicing with. So it's opposite b, so negative 48 plus or minus the square root of b squared, 48 squared minus 4 times a times c, all over 2 times a. So first, just plug it in, make sure everything's in the right spot. Now, normally I would say, oh, we'll stick what's under that square root inside the calculator. But this one, since I'm multiplying by 0, this whole piece goes away. And you can, of course, still use a calculator. I'm just showing that this one actually doesn't need it. Because once this part is 0, you just end up with the square root of 48 squared over negative 32 still. So this is just 48. So what I get is that x is negative 48 plus or minus 48 all over negative 32. Right, because a square root and a squared always undo each other. So it's just 48. All right, and now we have two different answers. So first one, negative 48 plus 48 over negative 32 would give us 0, because 0 divided by negative 32 is 0. Again, don't let 0 freak you out. It's just a number. Next one, though, negative 48 minus 48 over negative 32. This seems like a good calculator kind of problem. So let's see. I need 48 negative minus 48 equals divided by 32 negative equals, I got 3. So as long as you're writing down what you're putting in the calculator, it's fine to use calculators, but I need to see like that this is what you're typing in. So what this tells us, remember we're finding the x-intercept where y equals 0. So in this case, that means the height is 0 feet. And then we found 2 times when the time is 0 seconds or 3 seconds. Our two x-intercepts are 0, 0, and 3, 0. And you see those are also on the graph, but we were trying to find them algebraically, and that's what this looks like. All right, so hopefully that makes sense. You can see that y-intercepts a lot easier than x-intercepts. But let's try a couple more, make sure we got this. Example 2 says algebraically determine the x-intercepts. So first thing to remember, x-intercepts means y equals 0. So we're looking at y equals x squared minus 5. So that's 0 equals x squared minus 5. Now this is also a quadratic formula. X squared is the highest power, but we don't have that x middle term. You could use the quadratic formula, but you would be doing a lot extra work. Why not just add 5 to both sides and then square root both sides? Right? If we don't have an x in the middle, we can just use the square root property. And we should always be on the lookout for that because it's always easier than this mess, right? This we just had to do because we had both. Now we don't need to. One thing you have to remember though is the plus or minus. Anytime you use the square root property, meaning square rooting both sides, you have to use that plus or minus. So here our two x-intercepts will be at negative square root of 5 comma 0 and positive square root of 5 comma 0. If we were actually graphing this, then we might want a decimal approximation. So we would type 5 square root. So it'd be about negative 2.236 comma 0 and positive 2.236 comma 0. Because really where we're going is trying to graph these things. So, they would be equidistant. Make them look like that. All right, so we have negative square root of 5 and positive square root of 5 is where this crosses the x-axis, this parabola. All right, now it says y-intercept. Y-intercept, luckily, is always a lot easier. All we do is plug in x equals 0. So y equals 0 squared minus 5, y equals negative 5. You barely even need to show any work on this. We should write it as a point though. All right, y-intercepts are points, 0, comma, negative 5. So we just go down 1, 2, 3, 4, 5. And already using just the intercepts, we can sort of get the idea of what this parabola might look like.